Hello guys, welcome to my channel. Today we will be exploring exponential weighted moving average, and I will be doing the scratch implementation. So you have read about this exponential weighted moving average, but you will not find like how they have implemented from scratch. So what I have done, I have tried to just implement exponential weighted moving average from scratch, and step by step I will be moving from mean, then cumulative average, then I will be calculating simple moving average, and then the weighted moving average, and from there I will come to exponential weighted moving average. Okay, so step by step we will be moving. So first let's see what we have in this graph. So this is a time series data which is varying with time. We are having data xn and it is varying with time n. Okay, so this orange plot is just the mean. By mean you can understand like whatever the data points we are having, it will be divided by the total number of data points. So that is simply a mean. But what is this light blue is indicating? Okay, so this is a cumulative average. So what do you mean by cumulative average? So here what you do, you take a data point and at what position you want to calculate. So suppose if you want to calculate for 125th data, okay, so you will be taking from 1 to 124 data, you will sum it on the numerator, you will keep it on the numerator and you will divide it by the 124. So you will get the average, cumulative average at the 125th position. Okay, so that is cumulative average. Now let's move to simple moving average. So here we will do the same thing. You will be taking the previous data, but here you will decide a window size. So suppose if you decide a window size of 5, okay, k, the first plot, orange plot, that is for k equal to 5. So k equal to 5 means you will be taking previous data but up to 5th position from the whatever at whatever position you want to calculate. So suppose if you want to calculate at the 100th time, okay, so you will be taking sum of 96th point, 97th point, 98th point and 99th point. So whatever the previous 5 value you are taking now, you will be taking as a sum of on the numerator and you will be dividing by the window size, that is 5. So you will get the simple moving average at the 100th position. Okay, so let's come to weighted moving average. So here also you will take a window size, but you will decide a weight to the whatever the previous data point you are taking in the window. So here you will if window size is 5, you are taking previous 5 data, but the weight here is all same. Okay, but here the weight will be linearly increasing or decreasing. So by increasing I mean like for the most previous data you will be taking a lesser weight, and to the most recent data you will be taking a higher weight. Okay, so like that you will be taking here. So this is called weighted moving average. Okay, so in weighted moving average you take either a linear or a Gaussian function to define that weights in the window size, but here in exponential weighted moving average you decide the weights using some exponential function, that is exponential decaying function you will be taking here, and you will decide the weight, and then those weights will be taken in the window size. Okay, so this is the function they have defined, they have used in the that library using Pandas or NumPy, but I will try to implement everything from scratch. Okay, so this is the function I have used to generate data frame. So I have used trend and seasonality, and I added some noise to generate this type of value with timestamp, and I have tried to plot it using scatter plot. Okay, so here is the plot. Now step by step I will move towards this exponential weighted moving average. So let's start first by calculating the cumulative average. Okay, so we'll be use the for loop for I in range whatever the data this value is having. So we will apply a length here. Okay, and here we will be taking sum of those value. Okay, so this data is okay, then we have df data frame. So we'll be taking the sum up to that previous one. we have to define a sum here, sum1 equal to 0, and sum will be like sum of every df value, extract the value column and then apply iloc. Okay, and we have stored in sum1. Now what we will try to do, we will create a list for this. So we are calculating cumulative average, so I will be say CAVG equal to some empty list. And now what I will try to do, I will try to append in that list. Okay, we will append a CA, cumulative average. So cumulative average, what I have told you, so the sum we have done, now cumulative average will be equal to whatever sum we have divided by that I. Okay, so since we are starting I from we are deciding I in the range, so it will be starting from 0, so we will add a 1 here. Okay, we have added 1. So our list is ready. Now what we will try, I will try to plot it. Okay, so plt dot scatter, I will use directly from here. And I will try to plt.plot, I will plot those C average. Okay, so x-axis I will be taking the timestamp only, the same timestamp, and that y-axis will be my C average. I can decide the color as well. Let's decide the color. I will take it as some green color. Okay, oh sorry, I forgot to. Okay, so first I will calculate. It is giving a value error. Okay, so I have ran this function. So this is, I'm taking a timestamp, simple timestamp 0, 1, 2, 3, 4. It will go up to n, whatever data I have taken endpoints as 100. So it will be having 100 data points, and these are the value I have decided. Okay, now let's move on. First plot it. So this is my data point, and now I will calculate the cumulative average. So here value is giving me error. Okay, that is value is capital. Okay, it is saying it's not iterable. Okay, so it is saying it's not iterable. Let's try this. Okay, so cumulative average is now calculated. Now I will try to plot it. So this is my cumulative average. So it is not following the correct that expected plot we want. So now let's move to, so this is the cumulative average. Now we will move to simple moving average. Okay, so simple moving average. So what we have said in the simple moving average, that we will be having some window size. Okay, so let's take a window size of say 5. Okay, so now we will decide a sum 2 equal to 0. Let's decide it's a simple moving average, so sm average equal to some empty list. Okay, now I will use a simple for loop to do this. So I will decide for I in range, I will start it from window. Remember this, window up to length, whatever length we have of that data frame, it's giving value. Okay, now, oh I forgot in. Okay, so I have decided a window size of 5. So we will be moving in that window only. So since my window size is 5, the I will start from 5. So what I have to take, simple moving average will be taking sum from the first data point up to that window size. So I will start with 1 and I will move up to 5th position. So for that I have to do the sum equal to sum of what will be taking df of value, okay, and I will locate it from where to where, from window minus I to that I position, okay. So window minus I, window is 5, I will be increasing, so it will get negative. So I have to apply I, because I will be iterating, so I will increase from 5 to I will increase to 6. So I have to take I first, then I will subtract it with the window. So for the first iteration, what I value is 5. Now window is also 5, so I minus 5 minus 5 will be 0. So we will be moving from 0 to I, that is 5th. So we will be taking the 5 data points from starting. Okay, so we have done the sum. Now what I will do, I will calculate the simple moving average. That will be sum 2 divided by whatever the window size we have taken. Okay, and now we will append it in the list. Okay, so dot append simple moving average. So this is simple moving average. Now I will calculate the simple moving average. So it is calculated. Now I will try to plot it. I will use it from here. I will paste it here, and now I will replace it with simple moving average. Color, let's take it as pink color this time. So okay, I am getting an dimension error. X and Y must have same. Okay, so there is a dimension mismatch. Okay, it is moving, it is missing 5 points from, yeah, you can see it is missing 5 points. So since we have decided the window size of 5, it is missing the first starting 5 points. So what we have to do, I have to decide not number type of thing. So I will decide nan, which will be like will take float of nan. So, and I will say that nan will be multiplied with, it will get multiplied with window minus 1. Okay, so what it is doing, since we are having window 5 and minus 1, it will be equal to 4. So 4 times we are just appending a nan value to the this simple moving average. So the starting 4th position will be filled with nan value, and the 5th position we are appending from here. So now it should work. Okay, so we are not getting any PLT timestamp. What is the year here? Okay, we are still missing a value. Okay, let's see where I'm missing. Okay, so since we have decided a window from 5 and we are taking I from 5 and we are having here 0, so it will move up to length. We have to increase by 1 because we want to take a total of 100 data points. Okay, now it should work. Okay, finally. So this is the simple moving average we have taken with a window size of 5. We can increase the window size and we can see whatever the variations is. So suppose I have done a window size of 10. Now let's see how it varies. So you can see like it has varied a lot. So whatever the extreme data points we are having, it is not covering the extreme data points. Okay, so let's again move it back to 5 window size. Suppose if I increase more, if I say it is 20, window size 20, now let's see, it is going more and more smoother. Okay, so I will decrease it again back to 5, and now this is following our data point. Okay, so now let's move to weighted moving average. So in weighted moving average, what I have said, I have said like we will be having a weight. So weight can be linearly varying, or it can follow Gaussian. Okay, so I will decide a weight. So weight will be a list, because we have to multiply it with the data points. Whatever data points we are having in the window size, we will multiply with the data points, and then we will find the average, and then we will append into this weighted moving average list. Okay, so again I will decide a sum 3 equal to 0. I have decided a weight. Now for I in range, I will simply use this window concept. It will be almost same only. I will use the window concept from here. Weight. Okay, and now I will paste it here. I will just replace it with weighted moving average. Window will be used from here. Window size is 5. Okay, I will do sum 3 here. It will be now weighted moving average. Sum will be 3, and now the denominator will only change. Denominator we will be taking this sum of whatever the weights we are having. Okay, whatever the weight list we have, it will sum all the weights and divide it with the sum 3, and we will append it here, weighted moving average. Okay, so weight we have to decide. So we already know the window size. Let's decide a function, define a function. We'll decide weight. So weighted data should get transferred. So whatever the sum we are doing here, it should be some weighted kind of data. So that weighted data will be here, and we will divide it with the sum of the weights. Okay, so I will define a function weighted data. Let's pass this data and weight. Okay, I will pass a weight here, and I will give it to the function, this function. I will pass it in the function. So I will decide here weighted data. Okay, so I'm calling the function here. I will a function should return, it will return a weighted data. Okay, let's say weigh data, it will return. So I have to decide a weigh data, weigh underscore data equal to some empty list, and I will use a for loop for I in range of this whatever the window size we are having, or the data point we are having. Let's say for window only. Okay, so we're having window size here, and I will try to add this weigh data. I will try to append into the weigh data, and we will appending what? We will appending this weight multiplied with the data. Okay, so we'll be appending here some kind of sum 3. Okay, so what will append? We will calculate some sum 3 equal to this whatever the data point we are having. We have already passed data, so I will do data dot ilog, and I will decide this whatever I we use, and we will multiply it with the corresponding weights. Okay, so now let's decide what will be the weight. So as I said, weight will be some Okay, let's first initialize the for loop. Okay, so I said the weight will be some kind of it will follow some kind of linearity. Okay, so what I will decide, I will decide a way. I'll decide way equal to some, since we are starting I from 0, I will take I plus 1, give a bracket, and now I will divide it with the sum of whatever the length. Okay, so whatever the window size we have decided, we will take the sum of all the window size. So since we have decided a window size of 5, so we will sum 1 2 3 4 5. So I will take range 1 to up to length of window, and I will add 1. So 1 from 1 it will go up to 5. Okay, it will add from 1 to 5, and we will be adding here as 1 2 3. So this is the weight, and I will try to append the way inside my weight. Dot append this way. Okay, so my weight is decided here, and this weight will be used here. So for I in range window, that is 5, and length decided of the data frame, I will be 5. I will be having some sum. Okay, let's try to run. Has no length. Okay, window is having no length. Okay, so window is already a int value, so I don't need to have. Okay, so now let's see. Has no length. Okay, window here also we are having no length. Plus 1. Okay, so window, inside window we have decided weight, and now weight is decided. Let's see. Has no length. Okay, everywhere I have decided I have just done the length of window, but it should not work. Yeah, so now sum 3 will be calculated equal to sum of this weight and data is passed into weighted data function. Weighted data function will come here, data will be passed, weight will be passed, weight will be taken from here. Okay, and now data, weight data I have decided a list for I in range of window, this window size, or I can decide length of weight also. Okay, it's the same thing only, length of window and length of weight is same only. So now sum 3. Okay, let's decide something as A, and I will add A. Okay, so weight data has been returned with using this function. Weight data will come here, it will do all the sum will be stored in sum 3, and sum 3, and it will be divided by weigh, and weigh average append WMA. Okay, everything looks fine. Let's see, and now I will try to plot it using the same plotter definition. So this will be replaced by weighted moving average. Let's decide the color. This time let's decide the color to be green. Okay, now let's plot it. Okay, so this is a plot for weighted moving average, and you can see it is more precisely following the data points. Okay, so now I will just copy everything from here, and I will use it in deriving this exponential weighted average. So only one thing will change. The weight we have decided linearly, now it will vary exponentially. So okay, let's decide exp weight. Sum will be sum 4. Okay, and then it is cool. Now exponentially weighted moving average. Okay, so one thing change here is like in the definition of exponential weighted moving average, we have seen the formula here. Here the formula. So here you see a term beta, and one is 1 minus beta. So what is this beta? So beta, you take a value from 0 to 1, and beta decides like most recent value, like whatever. If you take beta 0, so it will be like the least recent value will be taken. And if you say beta equal to 1, so that means you are taking you are giving more weightage to the most recent data, and linearly you are decreasing the weights. Okay, so and also theoretically it is defined like 1 by 1 minus beta decides the window size. So what I will do, I will decide the window size here. So I will take a beta value. Say suppose beta we are taking 0.9. This is the default beta value, and from here I will decide a window size. Window will be equal to 1 upon 1 minus beta. So 0.9, 1 minus 0.9, 1 by 0.1, that will be equal to window size of 10. Okay, so here window size we have taken 10. And exponentially moving average, here I will say window will be taken from this 1 upon 1 minus beta. And now the function, it will change here. Okay, so here we will decide exponential weight, exponentially decaying weight. So if you look at again at this formula, exponentially weighted moving average formula, here you see beta vt minus 1 plus 1 minus beta theta t. So this, if you try to expand this value, okay, so if you expand those formula, and you will come to an expression that will be equal to 1 minus beta times beta power window minus 1 minus I. So that is so I'm giving you a task. You try to expand this function, then you will somehow come to this result. You will say like weight is you are getting weight somehow similar to this function, this expression. Okay, so I have decided the exponential weight. Okay, so every time your window is changing, your I is changing, you will get a weight, exponential weight, and I will append it in the exponential weight list. Okay, now since you have got the exponential weight, I will try to normalize it, because we want this whatever the weight we are taking, it should all the sum of all the weights should equal to 1. Sorry, so the sum of all the weights should be equal to 1. But here if you try to find the sum of all the weights, you will not see like it is getting equal to 0. So what we will do, we will try to normalize it. So let's take a sum of this exponential weight equal to sum of this whatever in the exponential weight list. We'll sum it and we will find normal exp underscore weight equal to we will decide a for loop. So for whatever the w we are taking divided by this sum of exponential weight. So this w will vary in for w in whatever the list, whatever the value is in the list. So we are finding w by sum of exponential weight for w in exponential weight list. So this will give us a normalized weight. If you want to see, we can print the sum of this normalized weight. Okay, it should be equal to 1 only. Okay, so the same way we will use a for loop in this window size, and we will having this sum 4, and sum 4 will be sum of this weighted data. Here it will come as, our list is exp underscore weight. Exp weight will be coming here, and the data is here. It will be passed in this function, and weight data will be calculated. Length of weight data ilog weight times multiplied, and weight data will be appended. Okay, and weight data will be returned here. And now we will do the sum of all the data and store it in a sum 4. Okay, so sum 4 is found. Now sum 4 will be divided by whatever the sum of this normal weight exponential weight we got. Okay, so this will be coming the sum of all the normalized exponential weight will come in the denominator. And okay, so we will pass here the normalized weight, not this original exponential weights. We will pass the normalized exponential weight, and this weight will be passed here, and weight data will be calculated, and weight data will be returned here. We will do the sum will be divided by the sum of normalized exponential weight, and we will calculate the exponential weighted moving average, and we will append it here. Okay, everything looks fine to me. Let's run it. Okay, it is giving an error, can't multiply sequence by non-int of type float. Okay, we are having error somewhere here. Let's see what is the error. It is saying window is some float value. Okay, so I forgot to round it here, because window we want like int value only, so I will round it here. Now let's run. Okay, so also I have print the normalized exponential weight, sum of all the normalized exponential weight, and it is coming to be 1. So now everything is correct. Now let's try to plot. Okay, I will replace it with exponential moving average. This time color I want to give something like, do we have cyan? Let's try cyan. Okay, so this is the curve I got for exponential weighted moving average. So everything I have implemented here are all from scratch only. As you can see, I have used a simple for loop and just a mathematical formulation to just calculate everything. From cumulative average to exponential weighted moving average, I have calculated everything from the scratch. And now this implementation you can take as a reference and you can implement yourself. Or if you want to use this notebook, I will attach it in the description. You can go there and you can check it out, and you can do lot more stuffs using this. If you want to do it, since I have taken a one feature only, you can take multiple features. So every time you will call this exponential weighted moving average for each feature column, and you will append it in the data frame. And then you can plot it to see like how it is varying in the all different types of features. Okay, so that's it for today. Okay, bye.